Okay, I'm recording now. I'm going to share my document camera. Okay, so continuing this revision here, right? This is the gamma function, right? Gamma function. Now, this gamma function, this is gamma one here. Just like that. What is gamma alpha? Now, gamma alpha, okay? Gamma alpha. So this is gamma alpha here, right? It is flowing that beta equals to 1. Beta equals to 1. So if beta equals to 1 in gamma, right? In gamma, in gamma. So gamma alpha equals to E of y equals to e to the power y to the power alpha minus 1. So beta equals to 1 to the power alpha. Yeah. Now, if you do the integration, right? 0 to infinity, 0 to infinity, right? Y takes from 0 to infinity, right? So this is equals to this is the total product now, right? Yeah. This is equals to 1 over gamma alpha y this is equal to 1, right? Right? Therefore, now you cross multiply gamma alpha equals to that's how we get the gamma function. Okay. Now, what's about the beta function? Beta function. Beta description. Y distributed beta with 2 parameters, right? Right? Y distributed with 2 parameters and beta. So, F equals F equals it doesn't have any. Y to the power alpha minus 1. Power beta minus 1 over beta. Now, what is this beta alpha beta?
So it's 59.
No, this is the beta function now. Same thing like alpha function here. This is the beta function now. Huh? No, it's not that. Gamma alpha, gamma beta, gamma. Now, these questions are all in the homework. Now, expected value is what? What is mean for the data function?
Alpha over beta,
Alpha
alpha
over-
over alpha plus beta.
What is balance of data? Balance of data.
Alpha beta over alpha plus beta squared times alpha plus beta plus 1.
Is it correct? What is you say? Alpha beta. It's not right. Okay. So what I will do is now, since due to some kind of registration problem in the SenGate, so I will extend some maybe today is what Wednesday, right? Wednesday, Thursday, Friday, maybe Tuesday. By Friday you finish. Will that be okay? Homework two. I will extend 2 days more so that you will finish it. Okay. And it is all about how can I say, gamma and the beta, gamma and beta. And so sometimes you should be able to do the integration by parts. Okay. And I put all of them so that we can do the integration by parts. And some problems may be helpful to use the applet. Okay. So for the applet here, now go to the CMAT here. I'm looking for the resources here. Oh, okay. So it is in the resources here. So it is in the CMAT resources here. Okay. Oh, it is showing the. Okay, I have to share the different screen here. So here, so it is in the CMAT resources. In the CMAT resources here, it has a chapter 4 here, right? In the chapter 4, you have the gamma probability and the quantiles, and
compare the gamma density, right? Just like if you click the compare the gamma density here, do you see that one? Yeah, you see that one, right? So here you see now you have the alpha 1 and beta 1 here, right? So if you plug in the alpha 1 equals to 1 and beta 1 equals to 1, you see the shape is like the exponential, right? And for this one, just like the alpha 2 equals, this is for another one, 2, like you see this one here. So it means that it is showing the different shape for the gamma. Now, in your homework problem, you can use this to draw the graph, okay? If you need to draw the graph. Now here the another one here, so it is like the for the gamma probability, this one quantiles here. Now this you see this one here now, right? Now here, so for the alpha equals to 1 and beta equals to 2.4, it is showing the some example. Let's say it is 2 equal here, right? Now you want to find the probability that is beyond say 1.5. Okay. Now it is showing that the probability
For the parameter value of 1 and beta is not between the probability of this is 20%.
I got that problem. On the forward, it was saying something about 3 point. It was like when alpha is like, I can't remember, the beta was like 2.4 and X was 1.3.
So if you want to find the between these two, then you have to take a different. Okay. Yeah, this is answer. So it means that this is helping us for doing the integration, right? It is doing the integration here. Now, if you want to find this probability here, right? Now, say let's put a 2 over here, okay?
alpha equals to, let's say it's equals to 3, okay? 3. And beta equals to, let's say it's equal to, beta equals to 1.2. Okay, now less than 1.2. Now, if you want the probability that is x is larger than, let's say 5. Okay,
Like this one, right? Now, for this alpha equals to 3, y distributed gamma, right? Gamma alpha equals to 3 and beta equals to 1. Now, this is giving the probability that y is greater than 5, right? Y is greater than 5. So this is equals to 0.205. Now, if you want to find the probability that y lies between, let's say, 6 to 7, okay? 6 and 7. Now, in this problem, if you want to start that, then what you have to do is that probability, what you have to do, probability less than y less than 6 minus probability y less than 6. Right?
now use the probability y less than 7.
So y less than 7. Y less than 7. Right? Now, probability less than 6.
Less than 6.
Now, this probability equals 1 to 5. Right? Now, equal to this one, right? 70. 0.0. Right? So, yeah.
Now this is for the gamma. Now similarly for you can find for the beta here, you see, beta function here, beta density function, right? Now, beta density function, you have the two things here. Let's say beta equals to alpha equals to 1 and alpha equals to 1 here. You see, this is the uniform distribution. You see, uniform distribution. Now, let's put this one here. Alpha equals to 2 and beta equals to 2. You see, these are symmetric distribution. Right? Now, now another one here. This is a beta probabilities and the quantile here, right? Quantile here. Now you plug in the values of the alpha and beta here. Let's say this is equals to 1 and this is equals to say 3. Now like this one here, right? Let's say 5 like that. Now you want to find a probability that let's say it is greater than 0.4. Now you have the probability. Okay. So, okay. Now let's stop this sharing here. And these links are available on the in the resources. Okay, it is available on the resources. And I also send you the link in the announcement maybe a couple of days before with the title that helpful link for finding probability. I send you the link from the announcement. Okay, from the announcement. Okay, I'm going to share now my document camera here. Okay. You can see document camera here, right? Okay. Now, with this, we finish the chapter 4 now for the continuous. Okay, and now we are going to start for the bilateral system. Now in this bilateral system, we have two variables. Now in the chapter 3 and chapter 4, we are doing the one variable. Only one variable. Chapter 3 is all about the discrete random variable, but one variable. And chapter 4 is continuous random variable, but univariable, right? One variable. Now here we are going to do the bivariable, which is the two variable. And this bivariable is that you have two random variables, right? Random variable, two random variables. Now, giant probability distribution means that random variable, first random variable takes the one value, and the second random variable takes the one value. And joint means that joint with two random variables taking some values, and what is that probability? You get the idea? You have the two random variables. What is the probability that the first random variable takes this value, and what is the probability that at the same time second random variable takes that? And that joint probability is the joint probability distribution. Now we start with a very simple example. We start with a very simple example here. Now the simple example is that let's say that you have the two die, okay? That, right? Let's say y1 equals to number of dots in first die, and y equals to number of dots in second die. Now, random variable one can take the value first from 1, 2, 3, 4, 5.
Now this is the random variable for the first die. Now for the second die y, it takes the values. It also has a 6 die cases. 1, 2, 3, 4, 5. Now this one is now what is the sample? Is a first sample is that it has a 1 and 1. Right? So it has a 1, 2. So this means that what is the same data probability that y1 takes the value 1 and y2 takes the value 1. Right? That's what it is. Now let's say for this one here, it says that probability that y1 takes the value 4 and y2 takes the value 2. Now this kind of a distribution is called a joint because it has a random variable y1 and random variable. Now this probability equals what? This probability equals what? Huh? 1 over 6, right? 1. Because it is an equal probability and there is total possibility is 6 multiplied by 6. So there are total 36 possibilities, right? And these are now what I'm saying right now, joint probability. Joint probability. So joint probability means that y1 is the random variable and it's taking the value, and y2 is another random variable, it's taking the value. And y1 taking the value, let's say small y1, and y2 taking the value. And they are taking together, right? They are taking together. Right? And this jointly it means that there is some probability of occurrence. Right? There is some probability. And it follow the axioms of the probability. What are the axioms of the probability? The probability has to be greater than 0, right? And the total probability is 1. Okay, now let's go here. Now, bivariate probability distribution. So many random variable can be defined over the same space. Now it is giving some example, okay, some simple example. For example, a tossing of the pair of the dice, there are 36 sample points, right? 36 sample points. It is 6 times 6. That's what it comes to 36 here, right? 6 times 6. And those possibilities are 1, 1, 1, 2, and 16. Now, few possible random variable. So now here these are the possible sample space here, and the random variable that has to be mapped to the real line, right? It has to go from the sample space to the real line, right? So first random number y1, the number of dots appear in die 1. So that is also random variable. y2 equals the number of dots appearing on die 2. Right? Now y3 equals to the sum of the number of dots on the dice. Sum, right? To sum. And y4 equals the product of the number of dots appears on the dice. Product. Okay. Now, definition of the bivariate distribution, discrete type. Now we start with the discrete, and the continuous is just it is a same thing, but we will replace by summation by integration, right? Summation by integration. And some notation like in a discrete we denote by P, and for the density we denote by F, right? Let y1 and y2 be two discrete random variable. The joint or the bivariate. We are talking here the bivariate because we have the two random variables, okay? Y1 and y2. Okay? And it could be more than two. Later on it will be multiple random variables, okay? The joint probability mass function y1 y2 is given by the
probability y1 and y2 so that it takes this value. Random variable y takes the value y1 and random variable y2 takes the this is the y. Okay. And remember here, random variable is denoted by the capital letter here, right? And its value is denoted by the small letter here, right? And y2 denoted by the random variable y2 capital letter and the value small letter here. Now, where y1 and y2 is a pairs of the possible values for the pairs of the random variable y and y2. So it is the values taken by the, it is the order pair, right? It's an order pair. Joint probability is a statistical measure that calculates the likelihood of the two events occurring together and the same point in the time. It's a likelihood because we are doing with the probability. Probability means that a likelihood, right? How it is the probability of having the chances that it will occur. So it is a likelihood, right? All the things we are reading is the what is the probability, what is the likelihood, what is the possibility of occurrence, right? So it's a likelihood. But since it's the joint probability distribution, it means that the two random variables occurring at the same time. Okay, same time. This is joint probability is the probability of the event y1 occurring at the same time that the event y2 is occurring at the same time. That's what is called the joint. Okay, that's what it's called the joint. And now it is we are talking here start with the bivariate because we have the two random variable 1 and random variable 2. And if there is a more than two random variables, we can extend in the same way, and it is called the multi-random variables. Okay, multi-random variables, more than two. Okay, more than two. Now, properties of joint probability mass function. So it's a mass function because we are talking about a discrete random variable, right? So for the discrete random variable, we say the mass function. If it is a continuous random variable, what we say? In case of the mass function, we say that what is that word? Mass function and what? No. For a discrete, we say that discrete say we say that probability mass function, right? Probability.
Yep, C, D, F.
Yeah, what is that? J. That is correct.
Same.
Yeah, that is correct on a CDR. Density function, right? CDR, right? CDR, not a CDR, CDR. CDR is a inherent density. Okay, so remember those some kind of small terms, okay? Terms. Now it follows the properties like the probability has to be greater than 0, right? Greater than or equal to 0. So it follows that one, greater than or equal to 0. And sum of the total probability equals to 1 here, right? Total probability, right? Okay, so it's up to here, it's not a big deal, right? Now here it comes here. Now this is the same examples we are just talking a couple of minutes before. Example of tossing of the die, right? So y1 equal to number of dots appear on die 1. This is a random variable one, first random variable, right? Now, first random variable. Right? And y2 is the number of dots on the die second random variable. Right? Now here is the we want to find the joint probability, right? We want to find this is now showing the joint probability. So this is the joint probability. Joint probability. Right? Now here it is showing that probability that random variable in the first die it will take the value 1 and y2 takes the value 1 over 30. So all is 1 over 30, right? So in general, since it is the equal probability for every possibilities, so it is all has a 1/36 here, right? Now in the table format, you see, this is a table format, and we have the 1/36 probability for everything here. Okay, everything here. Now, another example here. Okay, another example here. Now, it's another example is about a local supermarket has 3 check counter. Let's say it has a 3 check counter. Okay, check counter. Say the check counter 1 equals to say check counter 1, check counter 2, and check counter 3. Let's say like this one. Okay, they have the 3 check counters. Okay, 2 customers. How many customers? 2 customers here. Choose counters at random. Okay, random, independently of the order, independent of the order. Let X denote the number of customers who chooses the counter 1, and Y denotes the number of who select the counter 2. Find the joint probability density function. Find the joint probability density function here. Now let's do this example here. Okay. What's the time right now? Okay. Now see here. Now let's say that a counter here, right? Now we are going to from the random sample space to the random variable. Okay, random variable. Let's say we have the counter here, right? Counter. Say the counter 1 and counter 1. Okay, it is in order. First choose the counter 1 first, and the second choose the counter 2, and another one first choose the counter 1, and another customer choose the counter 2. Same like the counter 1 and counter 3, right? Same like you can hear counter. First customer choose the counter 2, and second choose the counter 1. Okay, counter 1, and first choose the counter 2, and second choose the counter 2. First choose the counter 2, and third choose the counter 3. Okay, and say again counter. First choose the counter 3, and second choose the counter 1. First choose the counter 3, second choose the counter 2. First choose the counter 3, third choose the counter 3. Right. Now, X is the, what is the X is defined as a, X equals to the number of, X is the, X denotes the number of customers who choose the counter 1, right? Equals to, X equals to number of customers who choose counter 1. And random variable Y, number of customers who choose counter 2 here, right? Now we are going to define the random variable. Okay, random variable. Now here the random variable, what is the value of X here? X equals to what? 2, right? Because the both choose the counter 1 and counter 2. And what is the random variable Y takes here? 0, right? Now here, in this sample space, what is the random variable X takes the value? 1. What is the random variable Y takes the value? 1, right? Now in this case, what is the random variable X takes the value? 1. What is the random variable Y takes the value? 0, right? Because no one choose the counter 2 here. You see, Y is the number of customers who choose the counter 2, right? Now here, what is the random variable X takes the value? X equals to 1. Y equals to 1. Here, X takes the random variable 0. Y equals to 2 here, right? Now here, X takes the random variable 0. Y 1 here, right? Now here, X takes the random variable 1. Y takes the random variable 0, right? Now here, X takes the random variable
zero,
0, y takes the random variable,
1,
1. Now here, x takes the random variable,
0,
0, y,
0.
0, right? Yeah, okay. Now it's using this idea here, okay? Using this idea here. Now these are all the possible sample space here. Now this one here, 0, 0. So y x equals to 0, y equals to 0 means the probability of this one here, right? This one here, x equals to 0, y equals to 0. This is the probability of this one here, right? So, probability of this one is here now. Total possible cases is 1, 2, 3, 1, 2, 3, 1, 2, 3. Total is 9, right? So this probability of happening is 1 over 9, right? So you have the 1 over 9 here. Now, probability x equals to 0 and y equals to 1. Now x equals to 0 and y equals to 1 here. You see, x equals to 0, y equals to 1 here. This one here, right? X equals to 0. Where is x equals to 0? This one here. This one here, right? Right? So x equals to 0 and y equals to 1. X equals to 0, y equals to 1, right? So you have the two possibilities here, right? So you have 2 over 9 here, right? 2 over 9. Now, probability that x equals to 0, y equals to 2. X equals to 0, y equals to 2. Where it is? X equals to 0, y equals this one here, right? This one here, right? So this one here. So is there any other cases? No, right? So you have 1 over 5. You see? So in that way, you have this probability, joint probability function here, right? Joint probability function. Now it is 0 here. You see here, if x takes the value 2, then there is only 2 customers, right? Not more than 2. So it cannot take the value 1 here, right? Yes. There is 2 customers. If both of them went through this one here, sorry, when have choose the one here, right? First checkpoint, then there is no order of the checkpoint here. So it's 0 here. Now same thing here, right? So this is also 0 here, right? And this is also 0 here. Okay. Now this is also a little bit defined here, as we did this one here. Right? Same thing as we are doing here. So it is also defined here. Okay. X equals to 0, y equals to 0 means probability that checkpoint. C means 3 means that C3 and C3. That's what it's saying here. Okay. So in that way, we will construct the joint probability density function. That is the idea. Okay, that's the idea. Okay, so yeah, no, we will continue for the next one next time. Okay. Okay, I'm going to stop here. Any question? Any question? So I extend like the homework you in the next 2 more days, so you can finish it. And I'm going to stop recording here.